In this day and age, many technologies are on the rise, including unmanned aerial vehicles, also known as drones. Drones are one of the most potential upcoming technologies of today. Hi, my name is Noam Olsson, and for my Masterworks project, I explored the idea of building a drone with an Arduino and programming it with C++. For those who don't know what an Arduino or C++ is, you're in the right place. But I need to tell you what a drone is first. A drone is often referred to anything as something that flies and has a radio controller, like all the drones here. There are multiple kinds of drones that classify under this definition. Fixed wings, tricopters, octocopters, hexacopters, helicopters, bicopters, yes, these really exist, and quadcopters. Each of these drones have their own purposes, strengths, and weaknesses. So I picked a quadcopter as it's the perfect medium of complicated and simple. But how will I make the drone fly? Arduino. But what is an Arduino? An Arduino is a microcontroller board that has the ability to be programmed with a slightly modified version of C++. Arduinos have various pins, allowing loads to be wired up to it, such as lights, motors, sensors, and a lot more. Arduinos also have the ability to be connected to computers through printer cable ports. You can see the printer cable port right here on an Arduino. Now, the coding language C++ has been mentioned a few times. And if you're not exactly sure what C++ is, it's the programming language C, but with two pluses after it. Meaning it's a variation of C, which is a low-level programming language that's used to program most modern computers. The one issue is that unmodified C++ cannot interact with Arduinos. That's why C++ also allows what's called an API, or Application Programming Interface. An API allows a programming language to have more functionality, like adding functions or increasing compatibility. A few functions that Arduino's API adds to C++ are the following: digital write, digital read, analog write, and analog read. Now, here's where the complicated stuff comes into play. I assume you've heard of binary, the art of ones and zeros. Binary is just really what's known as a digital signal, representing true or false. A digital signal is the foundation of all electronics, and it's one type of signal that an Arduino can read and write. Digital can't do everything, though, and that's where analog comes in. An analog signal is a varying signal that can be a certain percentage of power, but instead of being represented from 0% to 100%, it's generally ranging from 0 to 255. This all functions by using a type of waveform similar to pulse width modulation, except instead of a sudden digital waveform, it eases in and out, which you can see on this graph. Then for those who don't know, pulse width modulation is the process of powering a signal on and off at such a rate it appears as though anything it's powering is at a certain percentage of power. This percentage is determined by the time of which a signal is on and when it is off. The one key role where pulse width modulation comes into play is electronic speed controllers, or ESCs, which require a pulse width modulation signal to be fed into them to determine the motor's speed. But one question remains: how can complex data be sent from a sensor to an Arduino with one of the mentioned methods? The I2C protocol. But what is the I2C protocol? Good question, Isaac. I2C is a protocol used within many simple devices, such as displays, gyroscopes, Arduinos, and a lot more. I2C uses two wires called the serial clock and serial data wires to transfer data between devices. They're both based on digital signals. The serial clock is the wire that sets the speed of which data is sent between devices, and the serial data is the wire that sends and receives the data itself. With these two wires, physical networks can be made with up to 120 unique devices on it, each with unique hexadecimal addresses. Yes, you can have 127 unique devices transmit complex data using only two wires. Now, jumping back to my project itself, what did I make in the end, and how did I make it? Here's my process journal. I started out with coming up with an idea. My first idea was to make a complex network of drones that can do various tasks, such as search and rescue, forest fire monitoring, delivery, and data collection. All you'd have to do is use the app and request a drone. The drones would all have charging bases throughout the island, and being able to have a drone land on it, charge, and take off for the next task. I realized this was a little too hard. I next refined the idea down to an autopilot drone with 3 charging bases that automatically searches for forest fires using artificial intelligence. It wasn't until Masterworks began that I realized there's also no way I could complete that. The only way to finish this project was to build a drone minus the charging pads and AI. So, I chose that as my project, and I happened to be getting into Arduino at the time. So I thought it'd be perfect for a flight controller. So after doing some research, I decided that I couldn't fit a conventional Arduino Uno on a drone. So I had to go with what's called an Arduino Nano. From this point of finally figuring out what I wanted to do, I needed to find and order parts. I first started looking online for the right frame, and eventually came upon a frame known as the DJI F330, which is quite common for drone builds like this. Next, I had to find the motors and other parts that were compatible. Before I actually found the rest of the parts, I ordered the frame, which came almost 2 weeks early, and the building process took about 20 minutes longer than it probably should have due to the lack of instructions that came with the drone. Though after 45 minutes of trial and error with placing parts around, it finally came together and looked great. But one problem arose with this frame. It recommends using what's called a 2212 size motor, which means it has a unique mounting system that has 2 parallel screw holes that are further apart than the other 2. An average mount has each screw hole at an equal distance in a square configuration, but a 2212 size is in a diamond configuration. You can see here, this is these 2 screws are slightly farther than this one. The final process in the actual building of the drone is the Arduino sensors, which arrived late. I did, however, have the ESCs, the Arduino, which turned out to be a lot smaller than I thought, and the motors. With everything I had, the timeline for the build and programming had to be extended. I was hoping to have a fully functional drone by April 3rd, 2023, and I had to extend it to April 13th, 2023. What I entirely underestimated is the difficulty and precision it would take to solder contacts as small as I did. It was roughly 3mm by 3mm traces. The one issue with my experience in soldering and tiny traces is that some of the board gets burnt. Nothing problematic, but you can see a lot of darkening around the traces. Now keep in mind, this is much larger than it actually is. So look, one of these dots on here is roughly what I had to solder. Later on that week, I tested the GPS, which did not work. I evaluated that the code I found online was unlikely to be the culprit and was likely my crappy soldering job. Later on, after a few painful hours of soldering, I got all the components soldered, though not connected. I also managed to plug in the ESCs to the motors. Right here, this is the ESC motor, or right here. Unfortunately, the process stopped at that point, concluding my drone creation adventure, but not future ones. I managed to get quite a lot finished if you put it into a different perspective. I managed to complete multiple tasks on the build, such as assembling the frame, mounting the motors, mounting the ESCs, gluing on 2 LEDs, soldering the GPS pins, soldering the gyroscope pins, definitely not exploding my Arduino Nano, learning about electronic signals, learning about how a drone works, and learning about C++. I believe with enough time, I could get the drone working, just not within the bounds of Masterworks program. Now, back in the early stages of this project, I wanted to publish the code, so I thought it would be perfect to use GitHub. Have you ever heard the term open source? Well, if you have, it would be referring to the use of GitHub to publish a project for anyone to use, and the source code being editable, hence the term open source. which means a software or program that has its code easily accessible or viewable. Though it may seem as though you could just go into a software's files and see the source, it's not that simple. You would have to search for the specific code files through large directories if the program has its source code visible, that is, in the first place. With GitHub, anyone can publish a program they developed, and skeptics can check if the program is legitimate or not. Whereas with checking the code for malicious intent post-download, it might be too late. GitHub also allows others to fork a project, meaning that anyone can make a copy, modify it, and publish their own version. GitHub also helps with project workflow, being able to access your project, or in GitHub, what's called a repository, and edit the code and files in a repository from anywhere in the world. After my friend Alexander James showed me the power of GitHub, I realized how much of a perfect candidate it would be for this project. After building half a drone and learning how one works, I wanted to take to the skies and find out how drones are used in industrial environments. I was lucky enough to schedule an interview with Cameron Chell, the CEO of a drone company called Dragonfly. I asked him an array of questions related to how Dragonfly came to be, how drones are used out in the field, and how drones are used in the Ukraine war. I first asked him about how he got started with Dragonfly and the creation of drones, in which he told us that he'd been tinkering and messing around and coming up with product ideas since he was 15. Cam told me that the project that got him to where he is with Dragonfly was a software he designed for GoPro and drones, where the GoPro would start recording if something cool came on camera. For example, you were filming yourself skiing and you did a flip, the GoPro on the drone would start recording. But what they discovered is that the market wasn't ready for it. At the time of the software's creation, nothing like ActiveTrack or what we have today was present. For those who do not know, ActiveTrack is a function on DJI drones to track a subject. After the creation of the software, they got the idea to adapt it for law enforcement as a third-person view. Where in his research, Cam discovered a small startup company called Dragonfly that built law enforcement drones. So Cam built up some investors and bought the company and turned it into what it is today, a large corporation that builds drones for all fields, even the Ukraine war. So one evening I was looking at Dragonfly's website and I saw something called DroneAid, and I decided to ask Cam about it. Cam told me and Scott that DroneAid is currently a charity, but in the future will be an advanced software that creates a network of drones that anyone could put a drone on. DroneAid would release during or after a disaster and look for anyone in need. After Cam told me about this, I was immediately reminded of something I was previously trying to create in this project. After I interviewed Cameron Chell, he offered me the incredible opportunity to take a tour of their Burnaby-based office and prototyping warehouse. After a month or two of organization, it happened. Scott and I drove out to Burnaby to take the tour. Upon arrival, we met up with Cam and his kids to begin the tour. As we were pulling up to the building, I noticed no sign with the Dragonfly logo on it, only CanDrone. I later learned that CanDrone is a drone dealer that carries DJI drones, among Dragonfly drones too. Upon entering the unlabeled Dragonfly building, we were met with some very friendly faces who were happy to show us around. When we entered the prototyping room, I saw a drone on almost every surface. One of our tour guides, Van, gave us a rundown of how they 3D print custom parts for the drone and model it all in CAD on site. We then took a look at some of the drones being made there, with one octocopter being too large for a single person to carry, right here. After being given that tour, we walked over to CanDrone and took a look at the DJI Matrice 300 RTK. This is one of DJI's newer industrial drones with massive capabilities. The Matrice 300 RTK has various payloads that can be placed upon it, such as gimbals with different sensors on them, each costing up to $20,000 Canadian. That's the sensor that we had on it. That one, I think, was worth around $13,000. Oh, okay. After Van explained the Matrice and all its capabilities, we drove out to Ioko Park to give it a test fly. Van had put a thermal camera payload on the drone with a camera up to 20 times optical zoom and 200 times digital zoom. For those who don't know about camera stuff, that's really crazy zoom. Because there were kids there, Van gave us the challenge to drop water balloons on a target from 30 meters in the air, which ended up being quite difficult due to the gimbal's ability to have negative pitch, meaning I could not aim accurately. After we completed the challenge, Van let me mess around with the drone a little bit and explore its abilities. The incredible zoom on the drone provided the active track feature, which allowed me to have the gimbal focus on a car and track it. To my disappointment in this project, I never completed the drone, but I made some great connections and learned a lot, as I had no idea what I was doing in the beginning. And now I know more than I ever knew I would. And I hope you've learned some things too. I may have even gotten a new job opportunity. I'd like to give a big thanks to Scott Harrington for guiding me along this journey, Mark Olsson for guiding me along behind the scenes and also helping me see the project timeline, Sean Olsson for assisting me in the soldering, and among other things. I would like to thank Tammy Sanhedrai for helping me with the chunking of the project, Jennifer Henriksen for coordinating Masterworks and giving me time to work on Masterworks instead of learning about polynomials. I would also like to thank that dude, Van, at Dragonfly, for giving us the tour, and also all the other Dragonfly employees who helped out that day. And last, but nowhere near least, I would like to give a huge thanks to Steve Elves for teaching me about Arduinos and all the concept I learned to do with Arduino's technical side. Thank you all for watching and listening. Thank you.
Mr. Olsson, incredible job. I'm sure there's lots of interested audience members that want to ask you even more about what your topic is going into. But first we're going to start with your advisor, Scott, and the leading session.
Great work, Mr. Olsson. I am so inspired by your passion for this technology and your commitment to it. It was wonderful working with you and learning along with you. I know that you've acknowledged here that you didn't get what you originally hoped, which was a functioning drone, but along the way you learned so much. My question, the first one to you, is what do you need to do if you had the time right now and were able to dedicate it to that? What would have to happen? What would you need to do to get this drone in the middle flying?
Well, I would have to do a lot of soldering. So I'd have to actually fully hook up the batteries, get battery connectors on there so I could actually power the drone. I'd have to get all the sensors on here soldered and screwed down. I would have to get actual propellers. These are just for show, so you could know that this is a drone. I would also have to do a lot of programming. So I would have to program the Arduino Nano to take input from a controller and fly.
Right. And the sort of follow-up then is, do you think you have the knowledge and skill to execute that final bit you just described, the wiring and all the physical stuff, as well as the coding?
Yes, I do think I have the skill.
Awesome. You also mentioned right at the culmination of your slide that you may have even may have the opportunity for something about a career, you said, or can you elaborate a little bit? Because I remember the moment when you were at Dragonfly.
Yeah, so I guess I noticed that my whole project is about this, and that I maybe knew the terminology that they were talking about, because there's a lot of complicated topics when we were over there. I'm not sure if this is actually true, but maybe my insane drone flying skills while I was there.
Yeah, and if I can, just for the audience's benefit, I mean, it was so wonderful to be with Drone in the presence of these high level technicians in all things drone related. And what I was so impressed with, Noam, is you were asking the questions that were so significant and timely, and you were comprehending and understanding their responses. And it seemed to me that invitation that was there by these experts in the field was, keep in touch with us, because you're the type of person that's passionate about drones that we see and that we were, and now they're, you know, in that capacity. So kudos to you. Who knows how that may play out. But again, congratulations, Mr. Olsson. Wonderful job.
Thank you.
Pause a little bit to welcome everyone who's online, because we weren't online in the very beginning. So thank you for coming in from Holland and Israel to join Noam today for such an awesome presentation. Yay. The question period is on. I'm gonna, Steve, do you have a question? Because I think you worked with Noam quite a lot in coding.
Yeah.
Give him a really good heart.
Yeah, I worked with Noam quite a bit, Mr. Olsson, I should say, yes. And I was tremendously impressed with your depth of knowledge and your abilities with C++ programming. I have to admit, he's better at it than I am. He's got a real in-depth knowledge of how to put the programs together. My background is in industrial control systems, so it's a little bit different. He's got this microcontroller stuff down pat. What I'd like to ask you is, had you intended at some point, if you'd had the time, to have the drone be self-stabilizing, that you could put it in a hover pattern, for instance, and it would manage to keep itself in the correct orientation?
Yeah, that was my intention in the first place, to have a fully stabilized quadcopter. So I would use the gyroscope and take the inputs from the angles and counter that using the propeller's force. So that was the plan, yeah.
Oh, wonderful, wonderful. Thank you.
Cool. Thank you.
I have a question for you. When I read your paper and learned about what you initially wanted to do, and you talked about that, it was really uncanny how drone aid was exactly what you were thinking when you first started. So can you tell the audience a little bit more about drone aid and potentially how you or anyone here who's interested could get involved in that?
Yes, so DroneAid is, like I said in the presentation, currently a charity where you can go donate on Dragonfly's website. But in the future, it will be on GitHub, like I intended to do this, where you can put the code and the program on your own drone if you built one, and it can join a network of drones that will be released during disaster and look for certain symbols on flags, which could mean I need help, urgent, or we have an injured person here, it's not urgent, but just so you know, we are injured. Or maybe just we're here and we can't get out, or something like that. So DroneAid will be worldwide and everywhere. So, yeah.
Lots of questions, Mr. Score, why don't you start?
Amazing job, Mr. Olsson. Very interesting presentation. My question is, what do you think the biggest upside and downside of drone technology is?
Ooh, okay, that's a good one. I think the biggest upside, the best part of drones, is that they fly. So they can do everything from the air. So they have incredible data collection abilities, but that's also their downfall. So what, say, Dragonfly does, they take their drones, they fly over areas, and they do mapping and stuff. So they actually had a job once where they had to turn the entirety of Chilliwack into a 3D model digitally. So that could be an upside. They have incredible data collection abilities and can do incredible things like that. But at the same time, there's some sensors on them and things they can put on them that can also get incredible personal data that could be a scare for the public. Like they have facial detection, heart rate detection, blood pressure, all from the air. So you might not even hear it coming, and they're checking your heart rate from the sky, and they know who you are.
Okay. What is something that you, this is a very generic question, what is something that you learned? Like, what is your favorite thing that you learned?
What is my favorite thing that I learned? I think that my favorite thing that I learned is how they prototype and build drones, how drones are prototyped. So they actually they have this massive warehouse, and they have like 3D printers, CNC machines, and they're just 3D modeling on their computers, and they're like, I think this could work. They load it up into a 3D printer, wait 30 hours, and they have parts for a drone.
So,
Yes.
Mr. Lee, come on up.
Fantastic presentation, Mr. Olsson.
Thank you.
I was just wondering if there's anywhere where we can support you on your drone journey, like possibly a YouTube channel.
Oh yeah, if you guys want to see more of my drone content, check out Noam Drones on YouTube.
Yeah.
Also subscribe to Into the Horizon Productions because cool is cool.
We have some internet sensations in the room. Go ahead, Jared.
Yeah, Mr. Olsson is very, very well done, and some of the most interesting conversations that you and I have had together throughout the year have been about the future of technology, because often you can have, a 30-minute conversation, but it's just by yourself, and I listen, and I think that every time I do this, you're so informed. Besides the sort of future of drones being used for surveillance kind of capacities that will send your heart rate, what do you think is the most exciting potential thing that's going to happen in the next few years with droning in a positive way? And also, at the very beginning of your presentation, you mentioned using drones for fighting fires. I was wondering if you could educate us a little bit on what that looks like nowadays as well.
Yeah, so drones can't actually be directly used to fight fires, as most of them are quite small, though there are massive ones, but they can't carry enough water to make a huge impact. But they can be really helpful for forest fire monitoring, going out patrolling. So instead of, say, someone using all the fuel to go in a helicopter and fly over, look, where's the fire, what's the hectare count? You could just have a drone, go up, fly maybe 200 meters in the air and fly and scan over a whole area and measure out what that is.
On that note, can you put an infrared sensor on a drone so it can
Yes.
find fires?
Yes, yeah, thermal cameras, everything.
Which is great, because I was talking about you last weekend after we had a house fire on Bowen.
Oh, yes.
2 days after that house fire, near my house in the forest was found a smoldering fire that was ash from the house fire. And so we were talking amongst ourselves as we were fighting that small fire. Wouldn't it be great if there was a drone with an infrared sensor that could go around where a fire, they think a fire might be, or after a lightning storm or something like that, to be able to find and locate those small fires before they turn into big fires. So I can get you a job. Mr. Sweet, come on up.
That was a great presentation, Mr. Olsson. I know currently there's a lot of concern around the concern about the ethics of drones in the military. What do you think of that?
Well, I think it's fine to have drones in the military. It can be quite helpful. I feel like if anything goes further with like AI technology in military drones, that's an incredibly unsmart idea and should not be executed until like maybe way farther in the future, and we know for sure that this technology is 100% efficient in this area. Because now I think it's fine to use drones in the military. It's all fine because a person is behind a control. But if we take that over and let an autopilot do it, there's no way I think that is ethical or fine. Drones are like, in the military, are like a fighter jet, but there's no person in the fighter jet. So it's, if anything, it's better.
Thank you.
Very well done, Mr. Olsson. That was a very engaging and informative presentation. Do you see a future for yourself in the drone industry? And if so, what would that be? Would that be building models or flying them yourself?
I think I do see a future for myself in the drone industry. I think flying would probably be where I'd like to go with it, because I realize now with building 2 drones now, it's a very hard and tedious task that is incredibly difficult. And if I were to get into the building of industrial drones, that's going to be even more tedious and difficult, and may not turn into a fun job. Yeah.
Amazing presentation, Mr. Olson.
Thank you.
Branching off of Hannah's question, I was wondering, would you ever consider maybe not building the drones, but prototyping them and creating ideas for new drones?
Yeah, maybe. That could be fun. Yeah, I guess there is one part where it might become quite annoying and tedious because, I mean, the wiring itself wouldn't be the tedious part, but the one thing with these is I bought preset frames. So like this is a preset frame. I didn't machine this myself or anything. Same with this. But the thing is with prototyping drones and stuff, you are spending hours on a computer 3D modeling the frames, prototyping, going through iterations, retrying, printing, spending 40 hours printing a single part, and it's like, oh no, I forgot this little part, throw it in the recycling, and then reprint it. You know, I don't think so.
And one more thing, sorry.
But possibly.
I know you have a 3D printer, and 3D printing is a big prototyping part of drones. I was wondering, were you considering using a 3D printer for this, or maybe for a future idea?
Yeah, I was considering using a 3D printer for this, but it just so happened that during the science fair last year, my mom wanted me to focus so much on it, she took my 3D printer away, and as I was carrying it up the stairs after the science fair, I dropped it, and it broke, and we haven't been able to get the correct bed. So, yeah, it broke at the worst time, so it's still broken. Yeah.
Go ahead, Kirsten.
That was an amazing presentation, Mr. Olson. And my question to you is, have you ever used like any artificial intelligence to like write your scripts for the drone?
Yes, actually that was my idea. You see, I know C++ to a point, but I would not consider myself proficient enough in C++ to fully complete that myself, so I was thinking actually about using ChatGPT to write the majority of the script for the drone, then like edit it myself afterwards. So, yeah.
Thank you. Well done, Mr. Olson. I thought looking at infinity was a complicated and hard to understand topic, and then you presented. And I went, okay, I got a lot of learning to do here. This is a fabulous topic, and you have a huge passion, which I was so impressed with your ability to share it thoughtfully, interestingly, and beautifully.
Thank you.
My question is, I had a really good one, and now that I gave you a compliment, I can't remember what it was. Okay. So there's been this idea that we will be receiving our stuff we order online from drones that'll drop it on our doorstep for a long time. How far off is this actually a reality you see, that there'll be zones zipping around the sky delivering toothpaste and whatever else we order online? Is this like a pipe dream, or do you actually see this coming? How realistic is this idea, and is it actually a good idea?
It's realistic for the mainland, I'll tell you that. Because, so say delivery drones have to be massive. So the drone that we explored at Dragonfly, that was 9 feet by 9 feet, the one that octocopter, that could carry 70 pounds. So that's a delivery drone. So those, they have a limited amount of batteries they can carry. So I see it as a future for, say, downtown Vancouver. You could have like some Amazon drone flying out from the Amazon warehouse, flying over and delivering something. But not in remote communities. We're not too remote, but I consider Bowen a remote community for a drone, because you'd have to fly a massive drone over the ocean and land it. Keep in mind that's a 3-kilometer gap there, so that'd be quite difficult. But yes, I do see it as a future.
Do you think it's a good future though, or are we going to have no birds because all the drones will take them out?
The drones probably won't take them out. I think it'll be vice versa. The birds will take the drones out.